Yeah, Jatinder. So, what is that we have discussed in the last session, Jatinder?
Yeah, we discussed, like basic high level, how the HDF, the Hadoop is like ecosystem kind of how it's organized and um, how the Hadoop itself in the like cluster, like in the rack systems, like how it is organized and what are the task job tracker and name nodes and at high level,
Yeah. So, we have seen very clearly how the 5 domains that we have are being organized. Let me
Srinivas, one quick question. How can we get the
yeah,
access to your presentations? We never have this access to your presentations if it's possible. If not possible, that's fine. If it's like proprietary. But if not, then
not
if
exactly,
yes.
not exactly, but these are not actually the presentations that has some sequence or something like. I generally use it to make the sessions to be, to
Okay,
be handy as part of the sessions.
I got
But
you.
what all been required to you to understand the aspects are being specially trimmed and been shared to you. So those things we are going to keep it as part of our material, which are accessible to you.
No, but not where is that accessible? That material is
Will
like
be,
now
will be
not
done.
accessible.
Will be done. Because as we are at the initial level, very initial
Oh, I
level,
got you. I got you. I
yeah.
got you. Thank you.
So
Thank
I'm
you.
trying to give you the basic aspects, but
I
I
got you.
think today you'll be having at least 1 or 2 materials uploaded as part of the blog access what is given to you.
Yes, thank you. Thank you. That's it. Yeah. Okay.
Yeah. Have a very close look at this diagram. Please.
Srinivas, I can't see any diagram there.
No, didn't get you. Come out again.
I can't see any diagram there. It's showing your PPT demo on Hadoop with data. That's the screen I can see. Yeah, now I can
Oh, it's
see
the
that.
primer to Hadoop. It's a diagram is there. It's called primer to Hadoop, the title.
Yeah.
Yeah,
You are
now
absolutely right. Yes. Because when I'm talking about Hadoop, it is very clear to you. I implicitly mean by core, which has both Hdfs and Mapreduce. Out of these two, again, I didn't need to talk very in detail about storage before I talk anything about the processing part. That is the reason why I'm asking you to see or to look at this one. The Hdfs block size is 64 MB and the file size is 128 MB. If the replication factor is 3 at the cluster level, this is what the scenario. Client saying, I want to write a file by name file 1 under the path, what is being mentioned. Like how you have I already mentioned that very clearly in the last session. Even here you will be having a root. You will be having root. Even if you look at this one, here also you will be having root. You have root. Under root you have the file system. Same like your Linux file system. So home user. So you see that here, maybe every user that I create at Hadoop level, I'll be having like this. Every user that I create at my Hadoop level, I'll be having a home directory. That's what being explained here. Like how, even at this one, if you see closely, you see that I have only one account here. That is why you have something called admin. If I have one more account, every account that I create here under users will be having the directory structure. And under that, I need not tell you, you'll be having, what you'll be having? You'll be having desktop, documents, downloads, you'll have applications, all specific to that user. Same like under home, that is the reason why you are being shown this kind of thing. /home/ben. If there is an account created at Hadoop level by name Ben, under home a directory has been created and all your files are being kept under that. You're going to keep all your files under that. So if you want to store a file by name file1 under Ben, you are requesting the name node. What you are requesting? I want to write. Please observe this diagram, friends. Then most of the questions that you come across as part of your Hdfs are being well addressed here. You are requesting the name node. You are requesting the name node.
Hello, Sunil. So, excuse me. Actually, the class is started just now, or just now I logged in because I have some logging issue. So just now the class is started.
Just before it started.
Okay, thank you.
Lavanya, right? Yeah, Lavanya, just before it started.
Okay, thank you.
So you have any difficulty understanding? We are talking about in terms of HDFS, how a file is going to be stored. So for example, here, if it is your Linux file system, you want to store a file, you have a way. You can create your files in multiple ways. If you take your Linux file system, you have different ways to create files. The way I say here, I also can say ls-al. I have something called work, and in that I have different directories. This is a regular practice to me, that I create a work directory under my home and I keep all my work related things under this. So all my stuff, my data sets, my different things, I keep it here. That's what my regular practice. I create a directory by name work. So here you can create files in different ways and you can preserve them. Same like if you want to store a file at your HDFS level, you have the process like this. The client won't write, yeah.
Sorry, actually I didn't attend few classes, last class also properly. So what is the HDFS means?
It is actually the file system specific to Hadoop. That is Hadoop distributed file system.
Okay, so this it will in the form of save it in the form of HDFS method.
Yeah, not in the form of HDFS. HDFS itself is a file system basically, like how you have your file allocation table model. You have ext3, ext4, NTFS. So there is a file system by name HDFS, which is a distributed file system that is specific to Hadoop. Hadoop distributed file system.
Okay.
So when I need to store my data using my HDFS, even here, as explained by me as part of the earlier session, you are going to actually for every user as part of the cluster, you can connect to the client machine and from there you can execute all your commands, or your machine can be a client as part of the Hadoop cluster. I'll explain you that part, but to make you to understand, if the client wants to write a file to Hadoop distributed file system, the request is being made to the name node. What name node is responding, you see, that is where it is been shown as a bidirectional arrow here. Client made the request and name node is responding, okay, the file one is of size 128 MB, that is what been mentioned here in the slide, and the HDFS block size is 64 MB. So your 128 MB file is divided into two blocks, or it's been sliced or chopped into two blocks, each of 64 MB. The name node is saying, okay, write block 1 on data node 1 and block 2 on data node 2. See here very closely. Write block 1 on data node 1 and block 2 on data node 2. That is what the name node has responded to the client. Along with that, the name node is also preserving /home/bin/file1 has got two blocks. Block 1 is stored on where, block 2 is stored on which node. That information is being preserved here. But if you observe closely, name node is not receiving your data and storing it on the respective nodes. Name node is only advising the client to cut this file into 2 blocks, each of 64 MB, and directly send from the client to the respective data nodes. So data is not getting transferred from the client to the data nodes through name node. No. Data is directly going from the client to the respective data nodes, but on the advice of the name node. That is why the write operation is happening directly from the client to the respective data nodes. So that is where I said just before, these diagrams are going to help you in understanding the concepts. These are not having any sequence basically. Like, slide 1, slide 2, slide 3, it will not be in that form. I take these diagrams only to make you to understand the concepts thoroughly. That is the reason why we compiled certain documents to give you the understanding of the concepts in a systematic way. Those documents are being shared with you so that they are more meaningful to you. If I share these presentations, what I am using, they neither will be in order nor has got any notes related to that one. They are just the diagrams. Some been collected from the internet, some been written by our own, and some been documented by my team. So it's a mix and match. So you look at this diagram closely, you understand how data is written to Hdfs.
Srinivas, one quick question here. How do the name node, there's no connection here. I know the name node and data node, there's no communication like link here. So the name node gets all the data node information from the client, like for the metadata?
Exactly. Not about the client. The name node doesn't carry the information about the name node only carries the meta information about the data stored on the cluster, data stored on the data nodes. If you see that metadata /home/ben/file1. So anytime in future, if you are looking for the file called file1, the name node will understand, oh, file1 has got 2 blocks. Block 1 is present on data node 1. Block 2 is present on data node 2, and their copies are present on these nodes again. That all information comes from the name node, because name node holds the meta information but not the actual data. Who is holding the actual data? Your data nodes are holding the actual data, but their metadata is being stored or preserved by the name node.
So there's no direct communication between data node and name node. There should be some communication.
No, communication is there. The communication is there. What sort of communication?
Okay.
All data nodes need to periodically send the heartbeats to the name node saying that I am live, or I am available. So such kind of heartbeats need to be sent for every, whatever the time frame that is being set by the admin, every 3 seconds or every 2 seconds or every 5 seconds, the nodes need to send the heartbeat to the name node.
Okay.
So that
gotcha.
The name node understands that these nodes are available. So I can use these nodes for storing the data, and these nodes has got these blocks. So all that information is present within your name node, and communication always exists. Not only that one, communication also will be between data node 1 and data node 2.
Oh, okay.
That is also there.
Okay.
Not only between the name node and the data nodes, between the data nodes also the communication will be there. It's possible.
Okay.
Srinivas, one more question, like client means is like here like Hadoop client, am I correct?
Client means like who is connected to the Hadoop cluster, like you, me and all, who is accessing the Hadoop cluster, that is called as a client here.
So cluster means like the client tool, you're saying that's the cluster.
No. Cluster means the set of nodes, like, where you have name node, data nodes, secondary name node, job tracker, task tracker, all these put together, we call it to be Hadoop cluster.
Cluster. Okay. So client means like the tool you're saying.
No, client means the machine that is connected to the Hadoop cluster to perform actions against your cluster, like, file saving or file accessing, job submission, all these things are being done by the client basically.
Actually, I'm working in Informatica. They have like an Informatica client tool, like we can install in our system, and the server will be in different location. So, can you connect with that Informatica so it's easy for me to understand what's the client?
No, that is different. Informatica, what the landscape or the architecture is totally different there.
Okay.
So you see, so this is what is your data warehouse, right?
Mm-hmm.
The data that is present on different systems, your marketing data, sales, ERP, supply chain management, your external data, what you do is you extract all the data from different sources and transform it in the way you want and load it into your data marts, and from there you perform your analytics. This is what is your data warehouse. So you have a client here that indicates to access the data that is being loaded into your data marts. That is loaded into your data marts. You connect to the database that is maintaining your data marts. That is where it is being shown here. I think you see the last, what I am trying to show.
Yeah.
You connect to that one. That is a client basically. But when it comes to Hadoop, it is not that. When it comes to Hadoop, if you look at this one closely, this is your Hadoop cluster, Lavanya.
Yes.
So where you have a name node, this is a rack basically. You see that very closely here. On rack 1, I have my name node set up on one server, my job tracker on a different rack. It's not necessary that it must be on a different rack, but job tracker should be on an independent machine. That is what the meaning there. All will not be set up on the same node. Your secondary name node will be on a different machine. Physically I am talking. But when it comes to a pseudo cluster, all these 5. What 5? Name node, secondary name node, job tracker, data node and task tracker, all 5 will be on the same node. That is the reason why we call it as a pseudo cluster. Pseudo. It is a cluster only, no doubt. Replication is not possible there, and you need to maintain all the 5 daemons on the same node, and you will be having the resource constraint. That is why it is best suitable for quickly doing some experiments or evaluate or understand how you work with the respective bundle. That's the only thing we do. It is not suitable for production or something like that. Now you see here, I have my name node, data node and task tracker present on one machine, which are all what are being shown in blue. They are called your slaves, where data node and task tracker coexist. Data node and task tracker coexist. Now, out of all these, you see here there is one green that is been shown, is called a client. Is also a part of your cluster which can access your cluster, or your laptop can join as part of the cluster by making the configuration setup on your laptop, so your laptop also can become a client as part of your Hadoop cluster. So I deploy the client configuration. I deploy the client configuration on any machine, then it becomes a client. So it is not an expensive process to the admin. Once your laptop comes into the vicinity or the network of the Hadoop cluster, I can deploy the client configuration on that machine. Then using that client configuration, see, client configuration means don't think, oh, there is something, a great process for that and all, nothing. So client configuration is just nothing but like how you need Java C, that is called Java compiler, and you need Java, that is called your Java interpreter. One second. So you have your Java compiler, that is Java C, and you say version here. It says what is the version of the Java compiler. Then Java, like how your Java tools are accessible to you from the terminal, same like you need to have this tool accessible, that is called Hadoop. I say Hadoop, I get like this. That is what I mean by the client configuration being made available. I think you got the point what I'm sharing here. Make sense? Lavanya, it makes sense?
Yes. Yeah. Yes, Srinivas, just yeah, you
can go I
ahead.
Understand that it may not be that clear to you, but yes, in a session or two, I hope you'll get adjusted. But before this, I advise you to talk to Sunil or Kavya to get the access to the blog and look at the videos, what is been covered. I think, I mean, quickly. By the time we meet in the next session, make sure all these videos, whatever happened till now, if you go through them, you get more clarity and you'll be able to work with whatever the concepts we are discussing in the class very comfortable.
Okay, sure.
Still you have questions?
Yeah,
Still you have questions, don't hesitate. Yeah, you can always reach me.
Yeah, sure.
At the end of the session or something like that.
Okay, sure. Thank you.
Srinivas?
Yeah, please.
Yeah, I have one quick question.
Please. Teja, can you be a bit close to the microphone and speak so that your voice is audible to us? Yeah.
Yeah, is it fine?
Better, somewhat better, yeah.
Yeah, my question is, in the real-time scenario, if I have a like office laptop or something like that, so how I'm going to connect to this Hadoop client? if I'm a developer, like what, like is my machine is listed in that cluster, or how exactly I'll be connecting to that Hadoop client?
That's a very, no, you will not be connecting to Hadoop client. Your machine itself is going to be Hadoop client. I mean, your laptop itself is going to be Hadoop client. You will not be connecting to Hadoop client again. See, if you look at the diagram what's been shown here, client also a part of the cluster. I think you noticed that here.
Yes. Client is also part. Okay.
So you go into that network, because to my knowledge, there are only two possibilities to set up your Hadoop cluster. One, physically on premises with the 5 node or 6 node or 10 node, you are going to set up the cluster. On premises only using VMs on a high configured machine where you have 512 GB RAM, 512 GB RAM, I'm saying here, I'm very clear. It's not an abnormal thing. 512 GB RAM with multiple processors and multiple cores inside each processor. I can create VMs. Each VM is going to work as what I'm showing you here. One VM will work as a name node, other VM will work as a data node, other VM will work as a job tracker, task tracker, like that. I can create 5 to 10 VMs on the same machine, and they work as a cluster basically. So each node is configured with an IP address. When I go into that network, I will be accessing that network, and if client configuration is being set up on that new machine that is entering into the Hadoop cluster, it will be able to access your Hadoop ecosystem. I mean, what I explained you just now, I say Hadoop FS-LS. If I say like that, I should be able to access the file system. If I need to access the file system, now see here, this is my Mac machine, and using this terminal, if I say, ls/, it is going to show me what is there at my root level. This is a centralized machine. I understand that this is, this being a new, it is a bit odd for you to understand this one. So your Mac machine has got a root. ls/, if you say, at root level you have this. ls/users, you say you have this one. ls user/admin, you have this one. Same like for the entire cluster what you are seeing here, there will be one root. Same like your Linux file system. Under that root you have directories, subdirectories and all that stuff. But if you look at that closely, a particular file might have been stored in the form of blocks on different nodes. But you see the naming convention for that. That is the reason why I have shown you something before. You see this diagram? Your name node is storing the meta information /home/ben, and you have a file by name file1. That is what the meta information or metadata with my name node. But physically where this is, see, if you look at my centralized file system, my physical and my file system both on the same thing. But when it comes to your Hadoop cluster, my file system, nothing but the meta information or metadata, is stored with the name node. I mean, what is root, under that root what we have, under that directory what we have, and how many blocks it has been divided, where those blocks, only those details will be present with the name node. But the actual storage will be on the physical machine. maybe on data node 1 or 2 or 3, depending on the space availability, your name node is going to decide where this requested file needs to be stored, so that anytime in future you request the name node, I want a file called file1, it immediately goes to its file system image, that is called FS image. From there, it looks for the file called file1. Immediately it identifies it has got 2 blocks, and those blocks are present on these nodes, and the replicas are present on these nodes. All that information I come to know from the name node only. But who is actually physically storing your data? Who is actually? Data nodes are the workhorses. Data nodes are the workhorses. They are the actual daemon or the machines on which your data is getting stored.
What Srinivas you told? Data node or?
Data nodes are technically called as workhorses.
Workhorses.
Workhorses. Horses. I mean, horse is the one which actually perform. I mean, in the real life, we call horse to be something physical or which is going to perform. They are the workhorses which actually stores the data, which actually takes the load. Is it your name node storing your data? From this diagram,
no.
Let me know, is it your name node storing any data?
No.
Name node will not store any data. Name node only will hold the meta information. What is the file name? How many blocks are there? Where those blocks are present? Where the replicas are present? Only that information is there as a part of your name node. But who is actually storing your data? Your data nodes only. So that is where it has been explained through this diagram, how the physical activity is happening with your Hadoop cluster. As a client, again client means, what is client here? What is explained, what is been shown?
The switch, the rack 4.
Yes. No, it necessarily need not be on rack 4.
For example, whatever.
Yeah,
any
example. Rack. Because we are talking in the form of racks and all, that is why we have seen. But even your laptop that comes into the visibility of this cluster, where your laptop also gets an IP address within the range of your Hadoop cluster, then client configuration is deployed. What do you mean by client configuration? I give you one classical example to make you to understand why we require client configuration on the machine to access your Hadoop cluster. Is because, say this is the machine on which you want to write your Java programs, then what is needed? What is needed?
And in Java.
Exactly. So you look at this one, Java C, test.java, Java, I really don't know what is there inside it. I compiled and I executed, I got some output. Like how I am able to use my Java compiler and Java interpreter, same I should be able to use my Hadoop also. That is what I call it to be Hadoop client. So this configuration is deployed on the machine to make that to be a client so that it can access the Hadoop cluster. Hope you got the point. So client is only to perform what is being shown by me here. Client is only to perform the operations like storing the data, retrieving the data, using the Hdfs or Hadoop command, and client is to submit the job to the job tracker. Client is only to perform these things. Client is not to store the data or not to hold any meta information. Client is only to access your Hdfs and MapReduce directly or indirectly, not for any other reason. Please look into this diagram once again, friends. Then you'll be able to understand what this indicates.
Srinivas?
Yeah, please.
So in that case, client is the one type of Hadoop framework. Is that right?
No, Hadoop itself is a software framework basically. The
Yeah,
same
but
is being
because
set up on the machine so that it is accessible from that machine.
yeah, but we install that Hadoop package on that client side. So through that Hadoop,
Yeah,
yeah, so it's a one type of, it's a tool. We are using that.
exactly. You see here, Apache Hadoop software, that is a framework basically. And that framework we set up so that
Right.
your Hadoop is accessible to you. Make sense?
Yep.
Look at this one, this diagram once again. I want to process my file called file1. Earlier I want to store the file called file1. Now I want to process my file called file1. Please look at this diagram. We'll have a discussion on it, don't worry. We'll have a discussion on it, but look at this diagram closely.
What is MapReduce, Srinivas?
So MapReduce is actually the programming model. As I told you, right, Hadoop implicitly means HDFS and MapReduce. HDFS is to store the data. MapReduce is to process that data. So you have the provision to store the data in the form of HDFS. You have the provision to process the data using your programming model called MapReduce.
Programming, what we are write the code that is called MapReduce.
Absolutely. You want to process the data, you are going to write the code using MapReduce.
Srinivas, I have a question. Prasad here.
No, didn't get you. Come out again.
I have a question.
Yeah, please.
Okay, let's say I have a, let's take a normal example of the some sales stores. I have a 5,000 stores. So in the 5,000 stores, I have a client machine and application server and database server. So this Hadoop cluster I'm going to install in application server or database server, like whatever server. So for each 5,000 stores, I'm going to install it. And I have a centralized database where exactly I'm going to process my store data through Hadoop to Hdfs to store like using the MapReduce. Is that the architecture from the store to central?
No. You need to come out of your traditional system, database and all that stuff completely.
Okay.
So that is nowhere related with your existing infrastructure and all. See, Hadoop is not meant for that basically. See, there is no comparative study between your existing infrastructure and Hadoop. We cannot do the comparative study. See, Hadoop is basically meant for storing huge volume and wide varieties of data because Hadoop nodes are linearly scalable. Today, the diagram what I've shown you here, I may be having only 3 data nodes. Tomorrow, if my need increases, another 5 data nodes I add, 10 data nodes I add, 20 data nodes I add, 100 data nodes I add. Of course, name node also should be capable of holding that much meta information. So time to time, you also going to upgrade your name node whenever you are improving or increasing your cluster. Your storage need increases. You are going to add more nodes to the existing cluster. Linearly scalable. And you can store any kind of data for the reason this store, whatever the storage that you are creating, this storage is a schemaless. And unlike your traditional RDBMS where you define the schema, only that data fits into that storage. If you are storing anything other than that, it is going to complain while storage itself. While storing itself, it is going to complain, no, not allowed. But Hadoop is not that. Let the data be anything, it allows you to store that. Because it is like your plain hard drive. Is your laptop going to complain anytime when you are storing a file? Your laptop complains, no, this file is not allowed? No. Any kind of data is allowed. But when you are storing the data inside your RDBMS, as the schema is already been defined, pertaining to that only you will be able to store the data. You cannot store anything other than that. That is where schema first. Schema exists first, then you store the data. But
So
here it
my
is.
Question is, So my question is how to process the data from the store to Hadoop. Like I have a store-based architecture which is having a customized architecture. Like I have application server and database is there. I want to process that to store data to Hadoop.
No. Yeah, that is where I'm coming now. So once the storage is been done, when it comes to the processing, Prasad, data will not be moved anywhere physically. That is where I'm trying to show you through this diagram. Data will not be moved physically. Unlike your traditional mechanism where your data is present on your RDBMS or your database, traditional RDBMS, and you query the data, bring it to your application server, you process it there and render it to the client. That will not be the case when you come to your Hadoop. Processing is going to be done with the concept of data locality. Where data is present, I will push my code to that place so that the data is being processed then and there itself rather than bringing all the data to one common place. Why basically we are going for Hadoop? As we cannot store the data on one machine, we are going with Hadoop. Why? Because you can chop the data into multiple blocks and store them on the Hadoop cluster so that you always can say you have a file of 20 TB. Observe this one, friends. Nothing abnormal. One file of 20 TB size is not an abnormal thing. You have a file of size 20 TB. Is it possible that you store it on your local machine? I mean your laptop and all? No, because your laptop capacity itself is 1 TB or 2 TB. You will not be able to store beyond that. So what I am doing, this 20 TB file, I slice it into uniform blocks, each of 64 MB or 128 MB or 256 MB, whatever it is, and push all those blocks to all those nodes. So your storage is over now. How your storage is over? Simplicity's sake, I mentioned 2 blocks, 128 MB, block size is 64 MB. But same you extend it to 20 TB. How many blocks will come? 1 TB is nothing but 1024 GB. 1024 GB is called 1 TB. Now if my file size is 20 TB, how many blocks I get? I think you understand. So your data is being stored, cut into pieces and already stored on different nodes. Again, bringing all this data to one common place and process it is meaningless. That is the reason why my processing is going to be done. See here, I submit the job to the job tracker. Job tracker is internally communicating with the name node. That is the reason why in the last discussion I mentioned, for storage we require name node, for processing also we require name node. If name node is not present, your cluster becomes unavailable. That is the reason why we call name node as a single point of failure, SPOF, S-P-O-F, single point of failure. Now, my interest is to process the data. So client submitted the job to the job tracker. Job tracker is internally talking to the name node, asking, the client is interested to process this data. I want to know where the blocks for this given data are located. Then immediately name node is going to respond saying, you want the blocks for this file. These blocks are present on these nodes. That is what the response being given to the job tracker. Job tracker immediately what it will do? Whatever the job it received, usually in the form of a jar file, that jar file is being sent to all the nodes where your data is present. So that jar file will be executed then and there itself on the same node. Data will not be again brought to one common place. Practically that is not possible. That is the reason why we are going in this way. Maybe when you are working with limited data and all these things, you are happy working with a centralized file system. But when your data grows beyond some limit, your traditional file systems not able to store, or your warehouses or your databases not able to store, at that level what we do. That is what we are trying to understand here.
So in your example, you're saying a 20 TB file. So where this 20 TB file is coming? Like where this is located? Somewhere in the server side it's located, right? To process this 20 TB file?
So where this 20 TB file is stored, that you tell me first?
So you're taking the data, 20 TB file data from the client. Somewhere this data is coming to process the Hadoop.
No. That is where you are mistaken again. That is the reason why I have shown you this diagram before. The 20 TB file is already stored in the form of blocks on the cluster. It is already been stored. It is not coming any now dynamically when you are about to process the data. Data is already been stored on your Hdfs.
How it's stored?
Data is already been stored in Hdfs.
How it's stored,
Now
Srinivas?
that data, yeah.
How it's stored? For example, I don't want to compare with Informatica, whatever I know technology I am comparing. In Informatica, we have to connect with the big data, BDS, or like the Oracle, or like whatever, like we want Teradata, we can connect and we can do the ETL processing and we can load it to the files or the Oracle or the any type of database.
Oh, I got your point now. I got your point now.
So same thing where it's where it's reading the data and the writing, I got it, like it's writing on the data node and doing the process inside the data node. I got that one. How it's reading the data. I hope this is the question, the one I think the other person
No
asked.
issue, no issue. I'll explain you that. See here. Your data is coming from weblogs, databases, other different sources. And who is bringing this data into your Hadoop cluster? Who is bringing this data into Hadoop cluster is your, I'll show you that one even. Yeah, look at this one. Data from your, you see that medical reports, your sensor data, your DNA data, your gene data, your genome data, your satellite feeds, anything you take. Let it be structured, semi-structured, unstructured, whatever. Data is data. All the data we are bringing into your Hdfs. How? In different forms again. In different forms again. How the data is being brought into your Hdfs is with the help of, your data is being brought into your Hdfs with the help of components like Flume, Kafka and all. That also I'll try to show you. We have the tools like, yes, see here. See, with Hadoop commands, you can bring the data into Hdfs. That is one way. Limited data, small data sets and all. By running the commands like Hadoop Fs, you can bring the data from local file system into your Hdfs. That all we can do. But in the real production environment, data is being consistently brought into Hadoop using the tools running forever, like Flume, Kafka, and all these things. So what these tools will do, these tools are being configured to read the data from sources and dump it into my Hdfs. Once the data is dumped into Hdfs, then I can start processing it using my Mapreduce directly or indirectly using my pig or hive kind of thing, so that it will be more easier. Prasad, you got at least now?
Hello.
Yes, this is what I'm expecting. Srinivas. So the client side, how the process is happening is like using Kafka. So this Kafka is installed in the application server. From there, it pulls the data, all the RDMS,
exactly.
all log files.
Not one time. It is a consistent thing. Your Kafka kind of is going to run forever. Keep on pulling the data and pushing into your Hdfs.
Yeah,
so what is the tool name?
Apache server.
Yeah. Your Apache server might be generating the logs with transactional logs, or maybe not only transactional logs, even web logs, like transactional logs. I mean, what's happening at the transaction level, that is also been logged, and every event that is happening at your server level, that is also been logged, right? So all this data, if you are interested, if you want. Yeah, Prasad.
Yeah, in this scenario, where is this Hadoop cluster is installed on which server? On the so you have application logic, your Kafka installed there.
No, this is your cluster. Whatever the green that is been shown, Hortonworks data platform, that is the cluster, Hadoop cluster. I mean, whatever you are seeing in between, this thick, you are bringing the data into your Hdfs. Let me give you a better picture than this one. So this is all.
What's this tool you told Srinivas? Like how it's Kafka.
Yeah, KFKA, Kafka. So we have tools like Flume, Kafka, Nifi, many proprietary tools, open source tools, different. It's not just one, two. I mean, to name, we have these tools, but there is no constraint that you need to use only this tool. Depending on the context and the type of the data you are trying to dump into your Hdfs, you may use the respective tools. But Scoop, Kafka and all, and Flume, Kafka and all these things been from Apache, they are free of cost, they're open source, can be used by anyone. Now see here, this is what your Hadoop ecosystem, Hadoop cluster, Prasad. where you have your commodity server cloud. All your data you are bringing into your commodity server cloud. That is nothing but your Hadoop cluster. Now within the Hadoop cluster, you are processing the data, and that processed data we are exporting. I mean, if you talk in terms of your data warehouse, I import into my RDBMS, nothing but my warehouse infrastructure. From there, I have my dashboards, my business intelligence applications and all already running or already set up and made available, so that your data can be analyzed. So in this context, your Hadoop is going to work like one more layer of ETL under your ETL. How? We are extracting the data from different sources. We are transforming the data into usable way, and then loading into the target database, nothing but your existing warehouse infrastructure. Extract using your Flume Kafka kind of thing. Transform using your Mapreduce or Pig kind of thing. Load using your Scoop kind of tool into your target database.
Sure,
So your
can you
Hadoop
repeat me this sentence?
Yeah.
If you don't mind, can you repeat me the sentence, whatever you told me? Like,
you extract your data from different sources using Flume, Kafka kind of tools into Hdfs. We transform the data using Mapreduce or Pig kind of components. And we load the data into the target database, nothing but your enterprise data warehouse, using your Scoop kind of tool. Because Scoop is a tool with which we can perform import and export activity between your Hdfs and your traditional RDBMS. So in this context, your Hadoop is going to work as one more layer of ETL under your existing ETL.
so
Make
what
sense?
is the yeah, it makes sense. The Spark, what is the I studied like online also, they have some Spark also. It's like a Scoop?
No. Spark is like your Mapreduce.
Okay, Mapreduce.
The processing engine. Spark is a processing engine, but the difference between Mapreduce and Spark is Mapreduce is a batch processing, and Spark is your in-memory computing. To make your processing more faster and efficient, not in every context it is demanded, but where it is required, we will be able to do the in-memory computing. Say, for example, your credit card fraud detection and your weather analysis at critical times. So all that is going to be done using your Spark. Spark is not the suitable candidate for every need. Though it is in-memory computing, very fast and all, we will not be using or applying Spark to every need. Only when it is required, because it is expensive. In-memory computing, right? We require more resources. So compared to your batch processing using your Mapreduce. Make sense, friends? See, I definitely understand your concerns. Maybe next few sessions also you'll be having somewhat glare. You go here and there. Things looks to be comfortable, but not able to get the picture clearly in the mind. So a lot of questions in the mind, still not clear. So this state will be continued for a few more sessions till you get the acquaintance with the Hadoop ecosystem and you start working with it closely. Okay, but even then, I'm trying my best to give you the diagrammatic visualization to make you to understand where your Hadoop fits in, what it is, what we do with it. This diagram is much more clear. If I straight away show you this diagram, it becomes meaningless to you. Now you see the same diagram. Unstructured data, structured data, everything we are getting into your big data, nothing but your Hadoop, nothing but your Hdfs and Mapreduce. Okay, and then from there you do different things. And finally, what is the goal? This needs to be made accessible to your analytics. That is the ultimate goal. Storing the data is not the ultimate goal. You need to store the data, process the data, and make that process data available so that analytics can be performed on that. That is what the goal of your any storage. Why basically you are interested to store the data? Not just I want to store, I am storing the data. I want to get meaningful insight of that data. That is the reason why I am storing it. Yeah, Prasad.
So the structured data, so we understand like structured data, how it processed, like in the real time also it's processed through, we stored in the RDMS. And unstructured data like logs and all, like messaging and all, so it's come as a file format to Hdfs.
Yes.
To Hdfs. From the Hdfs, Mapreduce process this data to Hadoop. This is the NoSQL data. It stores in the NoSQL database.
See, from Hdfs, Mapreduce is going to process the data, and that process data is again stored on Hdfs only. So you process 10 TB data, you get 1 TB data assume. That is again stored on your Hdfs only.
Okay.
Or you are interested, you can move the data into your RDBMS for further analytics. So what you do with the process data is been based on the context. And there is no thumb rule here that process data must be taken out from Hdfs or must be taken out from Hadoop. No. It all depends. You can use it within your Hadoop itself, or you can push it into your traditional warehouse. From there you run your analytics and all.
Okay.
Srinivas? Hello?
Yeah, please.
Yeah, actually here for example, we can take the unstructured data using the Mapreduce and we are storing in the format of HDFs in the nodes.
Yeah.
Okay.
No.
Then after transformation.
You need to understand one thing here. You are not storing in the format of Hdfs. The format is different and store is different. Hdfs is the store. In that store.
Yeah, I got that one. Mm-hmm.
Yeah. Please, yeah, go ahead.
You can go ahead. Sorry.
So once you store the data inside Hdfs, see, Hdfs is just nothing but a file system. Like how you have your regular file system, that is what you are accessing using your terminal here. I'm accessing the terminal, right? See, this is what. You want to create a file, what you do here. You want to create a file, you have multiple ways. VI I can say, I can create cat I can say, or I can use some tool and create a file. But in the context of big data, we will not be creating files. That is what we need to understand. Maybe to experiment and all, we are creating some files, and using your Hadoop commands, we are moving those files or deleting those files and all, we are doing it. We are manipulating Hadoop FS. If I say, see here, when I say Hadoop FS, it is giving me, these are the commands available. MV, CP, RM, RMR. What vision you are getting looking at these things? chmod, chown, chgroup, move to local, copy to local. You have cat command, copy from local, move from local. By looking into all these commands, what idea you are getting? Same like your Linux commands only. But in the true production environment, we may be working with the Hadoop commands to work with things. I'm not denying that. But I'm saying in the true production environment, we are going to make the setup in such a way data is consistently read from some source and dumped into Hdfs. That is a continuous process. And as an admin, we are going to keep the threshold of 70% or whatever the load. Once that threshold is being met, I add a few more nodes to my cluster to increase my storage. If that storage is nearing to fill, when 70% is being reached, again I add more nodes. Like that, as of today with Yahoo, we have a 12,000 node cluster live up and running. Still that number is growing. 12,000 node live cluster. I think it is more than 12,000, around about 13,000 now. These are the statistics sometime back. It might have definitely crossed 13,000. 13,000 odd servers running live as part of your Hadoop cluster to preserve the data. Still the number is growing. So your HDFS is just a data store. Whenever the need arises to store more data, I add nodes to my existing cluster and take it forward. Got the point?
So in this diagram, all the dashboards are coming from the RDBMS. Like we can connect to Hadoop directly, right? For the dashboards, Tableau, and all of the logs and all.
So you see very clearly, we are bringing data from different high volumes. Data flow is coming into your Hadoop environment, nothing but your commodity server cloud. Using my Mapreduce, I'm processing it, and finally I'm importing into my traditional RDBMS, nothing but my warehouse infrastructure. From there I'm generating the reports. So these are being shown in different blocks, if you see that one clearly.
Yeah, I got that. RDMS data is like that's a structured data. So if you want to create a dashboard using the unstructured data for logs, using the logs.
Even that, even that unstructured data, what we do, we process it using Mapreduce, okay? And on the top of that process data, if you are interested, we can project the structure. If you are interested, we can project the structure. How? By using Hive. Inside your Hadoop ecosystem, we have a component called Hive. Using that Hive, we are going to project the structure. And once you project the structure, you can start querying the data. Like how you are querying the data using your SQL. Same like you can query the data that is available on your HDFS. Even though it is a unstructured data, after processing is been done, we can project the structure onto it. Suppose projecting the structure is not possible, then we will be using the respective tools to understand the data and give you the meaningful insights.
So the Hive is a data access point, right? Not a database.
It is a database, in fact. I don't call it as a database, I call it as a data warehouse.
Okay.
Hive is a data warehouse for Hadoop, basically.
Okay, now I got you.
That is the reason why I am saying you already has got ETL. What that ETL is doing, I think Lavanya is the right person to say about this. Lavanya, so what is your ETL?
Hello.
No. In general, forget about Hadoop. What is your ETL?
Informatica.
ETL is something which extracts the data from different sources, right? Usually, database is only again. You may have sales data present somewhere. You may have marketing data present somewhere. You have production data present somewhere. All this data we extract from different sources with the intention of transforming into the way we need. For what purpose? So that we can load into what we can do. target database to further analyze. Isn't it this or not?
Yes.
Is what your ETL or not, Lavanya?
Yes. Can you?
You're able to see my screen?
Yes. Yes, I can able to see your screen.
So your ETL extracts the data from different sources, transform it using your various transformations, using Informatica kind of thing. We perform transformations and finally load it into your target database so that further analytics can be done.
Yes.
Same when you come to Hadoop, we extract. What we extract? Data from different sources, which I have shown you now. Transform. How we transform? Using your Mapreduce or pick kind of thing. Load. Where we load? Into your existing warehouse infrastructure we load. Why we are loading into existing infrastructure? Because analytics are already been attached to that one. Instead of me setting those analytics again, I am doing that one. If not, what I can do is directly on your Hadoop warehouse itself. What is Hadoop warehouse? Your Hive. Directly on your Hadoop warehouse itself, I can set up my analytics stack and do my analysis. I need not depend only on the external ways to analyze my data. I also can have my own way to analyze the data within your Hadoop ecosystem itself.
I got this point, Srinivas. Like my next question is like, what is the role as a Hadoop developer? What is my role here? Like I will do the Mapreduce.
Very good. Let me finish that. Then we go to the next question.
Okay.
As a developer, you need to understand how. Look at this one. To ingest the data. Ingest the data using Flume or Kafka or Nifi or anything. It is Nifi, not Wifi. It is Nifi. Okay. So that is what your first thing you need to understand. Once you inject the data, the moment I am saying inject the data, I need not tell you explicitly, I am injecting the data into Hdfs only. So after the data is been injected, we process using Mapreduce or Pig or Hive, and then maybe, I'm not saying that every time, maybe using scoop kind of Hadoop ecosystem component, we using Hadoop kind of component, we export the data into data marts. So what happens when I export the data into my data marts? I can do my, because already that infrastructure is in place. So as a Hadoop developer, you need to know how Flume can be set up to read the data from the sources and dump it into Hdfs. Now data comes. But initially, day one, I cannot explain you how Flume is being set up. That is why I make you to work with local file system. Local file system, I mean your local file system present on your Hadoop environment. Okay, so we work with the file system first before going to Flume or Kafka kind of thing. We see how we store the data on Hdfs, because without storing the data, processing is not possible. That is what the problem. If you don't have the data, what do you process? That is why we are focusing on storing the data. Once storage is been done, then I bring Mapreduce into a picture. How to process the data using Mapreduce. how to process the data using MapReduce. That we see. Next, we see how to process the data using Pig, Hive, and how to export the data using Scoop. Then we talk about Flume. Then we talk about Oozie. All these we learn to perform the respective activity as part of your Hadoop ecosystem. So as a developer, you are going to do all these things. Makes sense now?
Yeah. This MapReduce and Pig and Hive, or everything has different languages, or what is the difference between this MapReduce, Pig and Hive? Like I need high level, not
We'll
like
be
very.
seeing, yeah, we'll be seeing as part of our sessions, no doubt, but to give you the understanding, see, originally these components are not been developed by Apache. That is what one reason why we got these many components. Otherwise, if Apache might have developed the ecosystem, we might haven't got these many components, because you take a Pig or Hive. When you work with Pig or Hive, you get the immediate thought, tell me when I need to go with Pig and when I need to go with Hive. And there is no exact answer from anyone in the industry till date, because what you can do with MapReduce, you can do with Pig and Hive also. What you can do with Pig and Hive, you must be doing with MapReduce, because your Pig scripts are being translated into MapReduce jobs only in the background. When you write a Hive query and run it, it works as a MapReduce job in the background. So you look closely, you work with the Pig or Hive, directly or indirectly, it is being translated into MapReduce only. Okay, so it is been very clear that as a developer, I write a MapReduce job, or I write a Pig script, or a Hive query based on my need to process my data. You got my point. MapReduce is developed using Java. Pig scripts are developed using Pig Latin language, Pig Latin. And Hive queries are developed using your HQL, that is your Hive query language, or SQL kind of thing. I say either SQL or HQL, both the same, but I use the term called HQL, that is called Hibernate query language. So if you look at this one, Apache has developed your Hdfs and MapReduce. But later on, what has happened, looking at the complexity of MapReduce, what the companies like Facebook, if you see Facebook, Hive is actually developed by them. Yahoo developed Pig. So what they did is, after the development is done and started using internally as part of their ecosystem, they realized that these are really potentially good and easy for the people to implement. Then what they have done is, they have contributed the same projects to Apache. Now at Apache, these projects also became top level projects. But if originally might have been developed by Apache, I don't develop both Hive and Pig. I might have developed only one. But as these are being developed for their own convenience with the existing landscape and the existing needs, that is why we are seeing these as separate. But otherwise, Hdfs and MapReduce is sufficient. But to abstract things, I may need Hive. I may need Scoop to export or import the data between your traditional RDBMS and your Hdfs. I need Oozie to make my workflows defined and executed on demand. So each component is contributing its share as part of the ecosystem, so to finally drive everything as expected. But if you ask me the questions, why those many components, the only answer I can give at this stage is, these are not being developed keeping the need in the mind, the generic need in the mind. These are developed specifically to address their own needs within the organization. Later they contributed to Apache. That is the reason why we have these many components. Otherwise, we don't require these many components. Make sense, Lavanya?
Yes, it's clear. It's clear.
So if you ask me, Srinivas, when MapReduce is there, why I need pig? No answer for that. But one thing I can say is, even if you write a pig script, it gets translated into a MapReduce job and works like a MapReduce job and performs like a MapReduce job. Not like a MapReduce job only. But it is more easier. See, instead of you writing 80 lines of MapReduce word count program, I can finish it in 4 lines using pig. I can finish that using my pig very comfortably. Let me show you that one, then you'll be able to understand why basically we go with that.
Like here, like I don't have idea about the Java, like I'm zero. So how like we.
I don't think that will be a problem, provided you put your efforts.
I
Java
know
skill is mandatory. Yeah.
C++, I know, like I studied long back, so
Definitely you will be understanding easily. I don't think it will be that tough.
okay. So it's a full core Java. It's core Java.
Basic Java, yes, you're right.
Basic Java is fine, like not like advanced Javas, like
No, not you don't need servlets, JSP, CJBs, messaging. We don't need all those things. We only need basic Java. How you handle the exception, how you work with streams, how you work with collection objects, that's it. We don't need anything beyond that. Basics of Java is sufficient.
Okay. What about for the scoop?
Scoop is small tool. Hardly in half an hour, 40 minutes, you'll be able to master that tool. Scoop is a small tool to perform import-export activity between your existing infrastructure and your traditional RDB.
Okay. Thank you.
Scoop is a small thing, very small thing. It's a small component.
Because due to Java, I was thinking past 1 year, do I have to?
No. See, if you understand MapReduce life cycle, that is sufficient. You need not sit and write the MapReduce code. These days, no one is writing MapReduce code at the workplace. I'm talking in the production environment because it is expensive. Expensive in terms of what? Expensive in terms of development. It takes more time. It requires more skill. See, I'll tell you. Look at this one. You have something called this is a word count program in pig. Don't bother about what is written here, but I'm just showing you. I'm reading the data line by line, and I'm giving the line to tokenize to cut into words, and those are being made linear, and I'm grouping the words by word, and within the group I'm counting what is a number. Finally, I'm printing what is the word and how many times it occurred. I get the output straight away. My word count program. Same word count program, if I need to develop using my MapReduce, have a look at this one. Same word count program in Java. Same word count program, if needs to be developed in MapReduce, how much expensive it is, just have a look at that. See, this is not to raise a debate whether MapReduce is good or pig is good. No, I'm showing you, if it is a case of MapReduce, to write your word count program, now they didn't give program here, let me show you.
It's going to be 300 lines.
Yeah. It is going to be, yes. Here you see, MapReduce job, it's MapReduce job. See here. Of course, import statements are also needed. So this is the word count program. See here. This is a word count program. Whatever I am showing you here is a word count program. Now the same word count program, you can achieve it using pig with these 4 lines. Now tell me, you expect the client, or when you go to the workplace, they force you. I don't think you find psychologically upset people to trouble you. No, I want the job to be implemented in MapReduce, writing 500 lines of code. You think you find any person like that in IT, that they compel you to work only with MapReduce? Definitely in every case. They are not worried. As long as the output is coming or output is coming as expected, why am I worried whether it is done with your MapReduce or pig or Hive? I only bother whether I am able to get my expected outcome or not. Whether it is written using pig or Hive, I doesn't care. Same code, if I write it using my pig, it will come like this. 4 or 5 lines of code. Same when it goes to your MapReduce. It doesn't mean pig will replace MapReduce or Hive will replace MapReduce, because you are writing a pig script, but when you are running it, it runs as a MapReduce job in the background. So what is happening here? Only the pain of developing the code is being offered to the new component. But ultimately the core engine is the same engine. Massive parallel processing, that is MPP, is what the core for your implementation part. So you write a pig script and you run that pig script, it gets translated into MapReduce job, and that MapReduce job will get executed in the background without your knowledge. So even you write a pig script, you definitely need to have MapReduce in the background. But you may not be directly working with it. But you need to understand how your pig script is getting translated into MapReduce job, what lifecycle things are there, that you need to understand. If you are not able to understand, you cannot write decent pig scripts. If you want to write decent pig scripts, efficient pig scripts, you must know MapReduce and its lifecycle. For that sake only we learn MapReduce. We don't become ourselves to be very strong in Java and become strong MapReduce programmers. These days, no company is interested to use or make the resources to spend their valuable time on writing the code, which can be easily achieved through your pig or Hive. You got the point, Lavanya, what I'm saying? See, by comparing these two things, I'm not degrading one and I'm praising the other one. No, I'm showing you what is the practical difficulty. And from your end also, you should have the same perspective. Please don't ever say that pig is more easier to learn and more efficient to work with. No, I don't agree. Because ultimately these are being translated into MapReduce jobs. And they run like a MapReduce job in the background. Make sense, Lavanya?
Yes. Yeah, I got it.
So,
You know what?
I think ultimately, as a Hadoop developer, what needs to be done by you, I think you got. As a Hadoop developer, you should have the ability to ingest the data using Flume. That ingested data needs to be kept on your Hdfs. So you need Hdfs commands. That ingested data needs to be processed. That is what your MapReduce, pig, Hive, and all doing. And this data, this extracted data from the data set, that needs to be exported. Not every case, if needed, needs to be exported to your RDBMS. We have Scoop tool. To bind all these things as a workflow, we have Uzi. So all these components comes into picture one after the other, provided you understand your storage and processing quickly. Storage and processing quickly, I mean Hdfs and MapReduce quickly, so that we can focus on other things like pig, Hive, Scoop, and all those things. We can focus convenient. So please go through whatever been discussed today, friends. I have given you big picture. I advise you to go through the video must. Go through the video must. That is must. And all the videos before so that you get the bigger picture. And it will be easy for me to start working with Hdfs commands and make you to run programs and run them and see the outcome and make you to understand the life cycle. All these things becomes easy for me, right? So please go through this one, friends, whatever we discussed today once again, and understand how your Hadoop is going to form one more layer of ETL under your existing ETL. So once you get that thought or that picture in the mind, yes, you really will be working serious towards the components as part of this ecosystem. Any questions for today, friends?
Yeah, Srinivas, one question.
Yeah, please.
Yeah, so you mentioned that, so actually the Kafka is not a process engine. So you mentioned that the Spark is not required, it's not a default
One
to
second.
process.
Yeah, sorry, Prasad. Yeah, please.
So to process the data to Hdfs using Kafka, so actually the Kafka is not a process engine, right? So you mentioned that Spark is not the default to not to use
No,
it.
we don't process the data using Kafka. We only ingest the data using Kafka.
So it's going to be a push or pull from the Hdfs? It's going to be pull.
Exactly.
Oh,
so that is where I mentioned it here, right? To ingest the data, we use a Flume or Kafka to do that one, to ingest the data.
okay.
Ingest, I mean, bring the data into Hdfs.
Okay.
Processing is done using your Mapreduce or any layer built on the top of Mapreduce. Processing is done only using Mapreduce. Directly or indirectly, processing is always done using Mapreduce only.
Okay.
Processing is always done using Mapreduce, directly or indirectly.
And this job tracker and the name noders are listeners, or like, so how would the job tracker know that the file is available to process? Is it going to be listener?
No, they are not the listeners. They are the actual performers. They are not the listeners. You are getting that thing done only through your job tracker, because you are developing a job that should be executed somewhere, and you are executing that on the cluster. Who takes care of executing that one? Your job tracker. Because you cannot sit and monitor every phase or every step, right? You develop a job and submit to the cluster. Let it take 2 hours or 2 days to process the data. You are going to get the output. That's it. That all is been taken care by your job tracker. Your job as a developer is only to develop a job and submit to the cluster. That's it. Its execution has been taken care by. The job tracker. That pain is not going to be taken care by. That pain will not be taken care by the developer sitting before the cluster. No. I develop the job and I submit to the cluster. My part is over. I get the process data. How this process data needs to be used further, it depends on the context.
So job is scheduled in a resource manager, that whatever the job we are running it?
No, you are going to a different track again. See, resource manager, application master, all these things are advanced to your Mapreduce.
Okay.
I mean your Hadoop version. There are two versions, Hadoop 1 and Hadoop 2. Your resource manager, node manager, application master, all these things comes into picture with the new cluster manager called YAN, yet another resource negotiator. So in that context, you get all these things. That is during your execution when the job is being submitted. So before we talk about resource manager, node manager and all, we talk about job tracker and task tracker. After thoroughly understanding that, we go to yarn to overcome the limitation.
Okay. Yeah.
So, I mean, I understand, because you definitely here and there you might have gone through certain concepts and you might have attended some seminars or internal knowledge transfer programs. So you got some inputs, and these inputs are going to put a lot of questions to you at this stage. I appreciate questions, and I also want to warn you that this confusion state or ambiguity will be there for a few more sessions till you practically go and start working with it and see the outcome by running the jobs and all. Then slowly these questions and the ambiguity gets cleared. I'm not trying to bypass as of now, but to make you to understand the concepts thoroughly, the only way is I need to teach you the concepts. Then only you can understand it. But to teach you the concepts, I need some basics. That is the reason why I'm introducing name node, secondary name node, job tracker, task tracker, data node. I'm introducing. But deeper discussion on these things is going to happen practically when you are about to take up that particular aspect and do it. So in the coming session, we are going to talk more about how you work with Hdfs. So for that sake, I need some basics of your Linux commands from your end. Please go through the basics of Linux commands, friends. But before talking about Hdfs and all, I would like to set up the environment on your boxes. So that thing I will be doing it. That is a pseudo cluster. So for that sake, what is needed is I advise you to do one thing. That is, go to cloudera.com. Cloudera.com. Please observe this one closely, friends. You go to cloudera.com. There you can go to downloads, and from downloads you can download the bundle. That is the VM bundle. Let it come. So you go to cloudera.com. There you'll be seeing downloads. Okay. And downloads, we have quick start VMs. And quick start VMs, I advise you to download because this is a around about 5 GB file. That is why I'm asking you to download that and keep it ready. So you go to quick starts.
Srinivas, if you don't mind, can you please send me the steps?
No, don't worry. We are going to set up the environment in the class. But I'm asking you to download the file because downloading the file may not be possible during your session. Setup we'll do in the class, don't worry. So quick start VMs for CDH 5.8, and you select the platform, that is VMware, and click on get it now. It may ask you to fill in some details. No problem. You need not worry to give these details, and click on continue. You will be able to download. That is around about a 5 GB file. It takes time. That is why I'm asking you to do that before we meet in the next session. So that environment I can set up in the session itself, so that you will be able to understand how Hadoop environment can be set up from the bundles that are being downloaded. So this is the first step. And the next step is download VM player. That is called VM player. VM player. Download the VM player for your respective operating system. Whatever it is, if it is your Windows, you can do that. If it is your Mac, you can do the respective. So VMware Workstation Player. This is a free one. So you can download this VMware. Don't download Pro. Download VMware Workstation Player, which is free. Okay. Don't download the Pro one. So download this VMware Workstation Player so that you will be able to play that image what you are going to what you have downloaded in the previous step. So once these two are done, download this one and run it also, so that workstation player is being set up on your box. Then I can make you to get the understanding of how environment can be set up. Then we can talk about the Hadoop commands. So as it is a time-consuming process to download this file when you are in the session, I'm asking you to do it before you take the session so that your bundle is available. And also, if possible, the bundle what you download is going to be a zip file. Extract that zip file to some place, not in C drive. If it is Windows, don't extract to C drive because something goes wrong. You format the operating system, it is gone. That is why I advise you not to have that. So what needs to be done is, you need to extract that zip file, which is 5 GB. That also takes time, 10 to 15 minutes, depending on your OS and the resources available to your laptop. So if you are able to do these three things, I'll be able to set up the environment in the next session and start working on Hdfs. Then slowly your queries gets cleared on your own and you'll be able to understand the concepts more in detail. You get the graphical representation in the mind, right? So don't worry, friends. For small things, don't worry. Even if you are confused, but only thing is you follow the sessions carefully. I think you'll be able to understand the concepts. Even then, still you are facing the struggle. Never mind. At the end of the session, you have every right to ask. Srinivas, I'm not comfortable here. Let me know what needs to be done. We'll have a discussion probably end of the session. Because during the session or the beginning of the session, something specific to each person, if I discuss, others will get discouraged. So let us not do that during the session or in the beginning of the session. End of the session, all your queries will be addressed. But what is needed to everyone, that we do in the session only. We will not push it. Right? So please go ahead working with these things, friends, by the time we meet in the next session, so that it will be more fruitful. Great time ahead, friends.
Thank you.
Thank you, Srinivas.
Yeah, wonderful, friends. I'll catch up in the next session. Great time ahead.